Draw vector diagram for equivalent sequence vectors for unbalanced system. So actually in an unbalanced three-phase system, the phase quantities, that is either voltage or current, are not equal in magnitude or not separated by exactly 120 degrees apart. Using symmetrical components, these unbalanced quantities can be resolved into three balanced sets. Like you can visualize this. This is VA, VB and VC. These are the phase quantities. So these unbalanced vectors can be transformed to a symmetrical component or say equivalent positive, negative and zero sequence components. Like this is the positive sequence set with the equal value of the magnitude of the positive sequence component, and VA1, VB1 and VC1 are like this. Accordingly, this negative sequence component, the magnitude or the vectors are equally opposite or exactly opposite to the positive sequence components, like VA2 here, VB2 here, it is VC1, now it is here VB2. So it is exactly opposite to the positive sequence component, and here instead of VB1 it is VC2. So the phase shift is 180 degrees apart in negative sequence component, and the zero sequence component set VA0, VB0 and VC0, all the vectors are like this. Now these three balanced sets like positive sequence component, negative sequence component and zero sequence components have the relationship between the phase quantities and sequence component as VA can be defined as zero component, positive sequence and negative, so V0, V1 and V2 like this. Now second vector, that is VB, can be defined as V0. Here both are same in the magnitude, and now VB1 or say VB1 here is 120 or say 240 degrees apart from this. So if we consider VA1 as a reference, it is 240 degrees like this and 120 degree here like this. So it is 240, so A square V1, and here it is AV2, that is 120 degrees apart for the negative sequence. So VB can be defined as for the sequence component like this, V0 that is equals to this VA0, VB equal to positive sequence network can be defined as the 240 degrees phase shift apart, so it is 240 degrees phase shift apart V1, and 120 degrees apart V2, so it is like this. So zero sequence, positive sequence and negative sequence component for the B vector. Similarly for the C vector, V0, here it is V0 in the same phase shift as zero sequence component. VC1, here it is 120 degrees apart, so AV1, and here it is 240 degrees apart for negative sequence component, so it is 240 degrees of VC2 or say V2. So VC is equals to V0 plus AV1 and A square V2. Here A is equals to 1 at an angle 120 degrees and A square is equals to 1 at an angle 240 degrees, and A is called as the unit phase shift operator. The similar vector can be represented for current as well here. So the unbalanced current of all the phases can be described as the sequence component like zero sequence, positive and negative sequence. So these are the vector diagrams for the unbalanced system.